Hello, this is Mr. Ensler. Welcome to the Chapter 12.5 through 12.9 review. If you go through and do every one of these problems and feel like you understand it pretty well, you are going to be very prepared for the test. So, there are a few different lessons in this chapter, and I've split them up by lesson. So the first one that we're going to go through is 12.5, which is all about dividing polynomials. Now there's two ways that we do this. If you're dividing by a monomial, like in number 1, see how this is just a monomial? Then all you're going to do is divide each term by that monomial. Basically, let me zoom in here. You're going to take each one of these terms and divide it by 2ab squared. And if you want, you can take this little shortcut that I'm doing and just write 2ab squared underneath each one of these. But now we need to simplify each one of these. So we need to go through each one and say, alright, 4 and 2, can I divide those? Yeah, 4 divided by 2 is 2. A squared on top, a on bottom, that's going to give 1a on the top. Look at the b squareds. You have b squared on top, b squared on bottom. Those just cancel out. And we have a c squared left over. So that first term is 2ac squared. Minus, we still have this minus sign here, and then on to the next one. 8 divided by 2 is 4. A to the third over a is a to the second on top, because there are more on top than on bottom. Again, look at the b squareds, they just cancel out, and we have a leftover c. Alright, and the last one, 6 divided by 2 is 3. A divided by a, the a's just cancel out. In this case, there are more b's on the bottom than on the top, so you're going to have a b on the bottom, and then we have c squared that's left over, that will be on top. So that's our answer. It looks kind of funny because of that fraction at the end, but that fraction at the end is basically like the remainder. This says that when you divide, it doesn't come out evenly. It comes out evenly for a couple of the terms, but not for all of them. Now look at number 2. We're not just dividing by a monomial, we are dividing by a binomial. So, to divide by a binomial, use long division. This is where you have to put the polynomial inside the division box. I'm just going to rewrite it in here. And the divisor, the thing you're dividing by, we're going to put that outside. And you're going to start by looking at the first term in each group. You're going to look at the x and the x to the third, and you're going to ask yourself, what do I have to multiply x by to get x to the third? Sometimes I even go off to the side and write this. X times what equals x to the third? What would that be? And so you have to realize that it will be x squared. So you're going to write x squared on top here. I would put it on top over its like term. So x squared over x squared. Now, you have to multiply that x squared back by x plus 3. So first you're going to do x squared times x, that's just x to the third. We kind of already knew that because that was how we found out what this number was going to be in the first place. But you also have to multiply it by the 3. So x squared times 3 is 3x squared, positive 3x squared. And so then the next step is to subtract. And so you're going to subtract x to the third minus x to the third, so those just go away. But then you're also going to subtract 7x squared minus 3x squared. So 7 minus 3 is 4x squared. Then you're going to bring down the next term, and from here basically you're going to start over. So now again, we're looking at x, the first term, and 4x squared. And we're kind of thinking, alright, x times what equals 4x squared? What would I have to multiply x by to get it to equal 4x squared? Well, it needs a 4, and it needs another x, so 4x. And once you know what that number is, again, you need to multiply it back in. So the first one that you do, 4x times x, you already know what that's going to equal because it has to match the number that's currently there. That's why we came up with it. But then you also need to do 4x times 3. So 4x times 3 is 12x, positive 12x. And again, we're going to subtract at this point. Of course, the 4x squareds just subtract each other away. But then be careful here. We need to do 10x minus 12x. 10 minus 12. 10 minus 12 is negative 2x. And then bring down the minus 6. And we're starting over again. Now we're going to ask x times what equals negative 2x? X times what equals negative 2x? Well, the only difference between those two numbers is that this one has a negative 2 and this one doesn't. So we need to multiply by negative 2. And so then you multiply that through. Negative 2 times x is negative 2x. Negative 2 times 3 is negative 6. Hey, look at this. They match exactly. When we subtract, they're both going to go away. That means there's no remainder, and we're done with the problem. This is the answer. X squared plus 4x minus 2. We didn't have to have any fractions there because it just came out evenly. This one, when you divided it, it had no remainder. Let's do another one like that. Number 3. Notice we are dividing a polynomial by a binomial, so we have to use long division. I'm going to put the binomial on the outside. Let's write the polynomial in the box here. X to the third. Ooh, look what happens here. It skips. And what I mean by that is it goes x to the third, x constant. There's no x squared. So you have to leave a space for the x squared before you write 7x. And actually, not only do you have to leave a space for it, but we need to put in 0 x squared. And you'll see why in just a minute. So anytime you're using long division and it skips one, so to speak, it doesn't just go right down the line in order, you have to remember to put a 0 in there. Okay, we're going to do the same thing that we just did. We're going to say, all right, x times what equals x to the third? And it would be x squared. And then you need to multiply that back through. So we'll have x to the third. And then you also need to do x squared times minus 2. And so that's going to be minus 2x squared. And then we subtract. So the x to the thirds go away. That's what we knew was going to happen. But look at what we have now. 0x squared minus negative 2. This is why we need the 0 there. Otherwise it wouldn't make sense. You wouldn't have anything to subtract from. So 0 minus negative 2, if you type that in your calculator, actually come out as positive 2x squared because you're minusing a negative. So it really becomes like plus. And then you need to bring down the next term. And now we're going to start the process over. X times what equals 2x squared? Well, it needs a 2 and it needs another x. So positive 2x. And when you multiply that, you'll get 2x squared, but you also need to multiply 2x by negative 2. So 2x times negative 2 is negative 4x. Then we're going to subtract. Of course, the first ones go away. Now look at this one. I would definitely use a calculator for this. Negative 7x minus negative 4x. Or sometimes it can be helpful to just write it out. Negative 7x minus negative 4x. So you can either type that in your calculator without the x's, or realize that that's actually going to be a plus. So it's like negative 7 plus 4. And so you're going to get negative 3x. Bring down the 6. This will be our last one because we have nothing more to bring down. So again, we got to ask ourselves, x times what equals negative 3x? And the only difference between those is that this one has a negative 3 and this one doesn't. So it's just going to be negative 3. And you got to multiply that back through. And so that means when you do negative 3 times negative 2, that's going to equal positive 6. Hey, look at this one. This one, when you subtract it, they're also the same, and there's no remainder. That happens sometimes, where there's no remainder and it just comes out evenly, so you're finished. Okay, number 4, same type of setup. Go ahead and make my division box. Does this one skip any terms? Well, we have 48b squared, 8b, and then just a number. No, it doesn't skip any. It doesn't have an x to the third or fourth, but that's okay. As long as the first term that you write down, it doesn't skip any as you go. And then we'll have 12b minus 1 on the outside. Again, we need to ask ourselves, what do we need to multiply 12b by to get 48b squared? It might be helpful to write this one out. 12b times what equals 48b b squared. Well, let's take it apart, number and letter. If you just look at the numbers 12 and 48, basically we're dividing 48 divided by 12. What do you have to multiply 12 by to get 48? And 4 is what we would need. And for letters, well, this one has b, this one has b squared, so you need to multiply it by a b. So 4b is what we're going to multiply by. So 4b, you know, really you can put it anywhere on top of the line, but usually we put it above its like term partner there. And then we got to multiply this back through, so we're going to get 48b squared. We kind of already know that, that's why we chose 4b. But then you also have to multiply 4b by negative 1. So 4b times negative 1 is just negative 4b, and then we'll subtract. The 48b squareds go away. Careful here though, 8b minus negative 4b. 8 minus negative 4. So that's really going to be 8 plus 4, so we're going to get 12b. And then bring down the 7. This is kind of a short problem actually, because this is going to be our last one. Now that we've brought down the 7, there's nothing more to bring down. So 12b times what equals 12b? Oh, interesting. What do you have to multiply 12b by to get 12b? Nothing, but I guess 1 would be what we have to multiply by. So 1. Now you need to multiply that back through, so we're going to get 12b, but then don't forget to do 1 times negative 1 is negative 1. And when we subtract, the 12b's go away, but the other ones do not. We're going to have 7 minus negative 1. 7 minus negative 1. That's really 7 plus 1, which is 8. There's nothing more to bring down. That means 8 is our remainder. So what you have to do with that 8 is you have to bring that 8 back up to your answer and write out plus, because it's positive, 8 over your divisor, 12b minus 1. And that is your answer. It looks kind of weird, I know. That's because it didn't work out evenly. We have a remainder. That was new for this chapter. Okay, so that was lesson 12.5. In 12.6, we reviewed how to add and subtract fractions that already have a like denominator. And basically all you do is you just add or subtract the numerators, and you keep the denominator the same. So if you really want to show your work, what you'll do with one like number 5, since they already have the same denominator, you'll just combine them. You'll write m plus 4 plus m minus 1 all over 5. Now we're not done yet because we have like terms in this numerator. The m and the 4 and the negative 1. So you have to combine those. M and m makes 2m, 4 and minus 1 makes positive 3, and this is still over a denominator of 5. And we're either finished, or could we factor something and cancel it? In this case, no, you can't factor anything out of the top. There's no GCF, no way to factor it. So this is our answer. Let's do kind of the same thing with number 6. Notice number 6 is a subtraction one, but we're going to do the same thing with it, just with a minus sign. So we're going to combine these over their common denominator. That's already the same. And then we're just going to write 7a minus 5a. And can we actually do anything with that? Can we combine these? Yes, these are like terms. You can actually subtract. 7a minus 5a is 2a, and then we still have b squared on the bottom. Okay, before I circle this and say I'm done, is there anything I can do between the top and the bottom? Can I divide anything that's the same? In this case, no. Alright, let's look at number 7. It's an addition one. The adding ones are a lot easier, as you'll see when we turn to the next page, but let's go ahead and just combine these. They both have a denominator of 2n minus 5, so we'll just say negative 5 plus 2n. You know, usually when we have a number and a letter together, a constant term and a variable term, we like to put the variable term first. And usually I would say it doesn't matter how you write it, but in this case it's actually going to make a difference. If we rewrite this, so it says 2n and minus 5, and then we write our denominator down, do you notice anything about that? We have the exact same thing on top as on bottom. I could put parentheses around these just to show how the entire top group and the entire bottom group are the same. So actually what we can do here is we're not going to leave our answer like this or like this. We can simplify. These cancel. But the answer is not 0 and it's not nothing. Remember, when you cancel, you're actually leaving a 1 where you canceled. Sometimes we don't write in that 1 because we don't need to. There's other numbers there. But in this case, we do need that 1. So the answer here is going to be 1 over 1, or even simpler, just 1. And that is a lot simpler than what we started with. These two fractions added together actually just equal 1. Okay, 8, 9, and 10, we're just continuing on in lesson 12.6, where we're adding and subtracting with the same denominator. And I mentioned that subtracting is a little bit more difficult, and so we'll just have to watch out for that. All right, so in number 8, they already have the same denominator. I'm just going to write it as one fraction, and we'll just do 2x minus 6. Okay, you can't actually subtract those because they're not like terms. So either we're finished, or maybe we can factor something from the top and the bottom. Well, the first thing we always look for when we factor is a GCF. So is there anything that we can divide out of both of these terms? Yeah, they both divide by 2. So we're going to take out a GCF of 2. It's kind of like undistributing. And if you divide both those by 2, we're going to have x minus 3, and then I'll rewrite the denominator. And look at that, we have x minus 3 on the bottom also. So kind of like number 7, we can actually do something, and we should cancel this. And all that's remaining is 2. So yes, you do have to do that to get the final right answer. Let's look at number 9, another subtracting one. So on number 9, we'll just write them both over the same denominator of 5, but we'll make a subtraction sign. So x plus 4 minus x plus 2. But if you wrote it just how I did, like that, that's not quite right. And the reason why is because you're not just subtracting x, you're also subtracting the 2. Sometimes what I do is I draw this parentheses here, and we're going to distribute that subtraction sign. So it's actually going to be negative x, but also negative 2. So it's going to be x plus 4 minus x and minus 2 over 5. And we do have some like terms here. We can combine the x and the minus x. What does that equal? X and minus x. Well, those would just go away. And 4 and minus 2, 4 minus 2 is 2. So our final answer ends up to be just 2/5. Can't simplify that at all. And so we're done. Let's do number 10. You can see this is going to kind of be the same because we are subtracting more than one thing. You notice that we didn't really have to worry about that too much on number 8, and that's because we were only subtracting one number, just 6. And so that's not as difficult. But on number 10, we're subtracting more than just one number. We're subtracting x and negative 1. So you're going to distribute that negative to both of these. So when we combine these into one fraction, and with x minus 2 on the bottom, I'm going to write 3x plus 4, but then I'm going to write minus x, and what is negative 1 equal? That's actually going to be positive 1. From there, we can combine some like terms. We're still going to have the same denominator of x minus 2, but 3x and minus x is going to be 2x. 4 and plus 1 is 5. All right, can I factor anything from the top here? No, there's no GCF, no way to factor it, so in this case, we are finished. Now, the next lesson that we did after that is how to add and subtract when they are unlike denominators. This is a little bit more tricky because you have to make the denominators the same. And so the general thing that we're going to do is we're going to rewrite the fractions so that they do have a common denominator. How we're going to do that is we're going to multiply both numerator and denominator by the same number to accomplish this. So let's look at number 11. Now, when you make the denominators the same, you can't take away any parts of the denominator. You can only multiply them to make them bigger, or you could keep them the same. So let's just take this one number at a time. Let's look at 3 and 2. I can't like cross any of those out, but I can multiply them to make them the same number. So you got to think, what can I multiply 3 by? What can I multiply 2 by that will make both of these numbers the same? And so what you're really looking for is the least common multiple. And the least common multiples of these is 6. So you would have to multiply the first by 2 over 2. That way it's going to say 6. What would you need to multiply this one by to say 6? It would need to be 3 over 3. Alright, now that will make both these numbers equal 6, but what about the letters? Well, for instance, the second one has a C, and the first one does not have a C. I can't get rid of that C. But I can multiply it by the first fraction. Now let's look at the d's. This one has d squared, and this one just has d. I can't get rid of that d squared, but I can multiply the second one by d. So now watch what happens when we multiply these. And the rules say if you multiply the bottom, you have to multiply the top. So on the bottom, let's do the denominator first. 2 times 3 is 6, and then I have c, and I have d squared. Usually we write them in alphabetical order. But then you also have to multiply them on top. 2c times 2c is 4c squared. Look at the second fraction. In the denominator, 2 times 3 is 6, and we just have a c, and then d times d is d squared. Look at that. The denominators are the same. That's what we wanted. That's why we multiplied them. On top, though, I still need to multiply 3 times 3d, and so that's 9d. Once you have made the denominators the same, now this 12.7 problem is basically like one of these 12.6 problems, where you just combine them in the same denominator and you simplify as much as you can. So now that the denominators are the same, I'm just going to rewrite this over one common denominator. We're adding these, so 4c squared plus 9d. Can we actually add these together? 4 plus 9 is 13? No, because they're not like terms. Then I guess the only other question is, can we factor this at all? Can we simplify it? Can you divide 4c squared and 9d by anything? No. So we are finished. That is as simple as this one's going to get. Let's look at number 12. Now in number 12, we have two different denominators, r squared minus 9 and r plus 3, but we want to make them the same. And so you might remember that what you're supposed to do when you have a binomial or trinomial denominator is try and factor it. And if you factor r squared minus 9, that's actually the difference of two squares, r minus 3 and r plus 3. And the reason why we want to factor it is because it lets you see this denominator more clearly. It's like you're seeing into the denominator, you're seeing the details. And so now what you realize is that the first denominator and the second denominator actually have something in common. They both have r plus 3 in them already. And so all you need to do to make these the same is multiply the second one by r minus 3 over r minus 3. Look, just by writing that, you now see that these denominators are the same. So it's like we're not really going to change the first fraction very much. We did factor it, but that's not really changing it. That is just changing the way it looks. But we are going to change the second one. Now the second one is going to become r plus 3 and r minus 3. On top, I have to distribute to multiply that in. So I'm going to get 3r squared minus 9r. So now we can just combine these into one denominator. And I'm just going to recopy it here. R squared plus 21r plus 3r squared minus 9r. Can any of these terms be combined up here? Yes. This 1r squared to begin with is like terms with 3r squared. So you combine those and you get 4r squared. 21r and minus 9r, you can combine those. Those are like terms. What's 21 minus 9? 12r. And on bottom, we still have r minus 3 and r plus 3. I like to keep it factored like that. I suppose if you really wanted to, you could write it as r squared minus 9. But usually we keep it factored. That way we can tell if anything else can cancel with it. So at this point, we've combined everything. Either we're finished and we circle this, or we ask ourselves, can we factor anything from the top? Is there any GCF between 4 and 12? Yes, there is. You can divide a 4 out of both of those, and they also both have an r. Now, maybe we'll be able to cancel after we do this, maybe not, but if it can factor, you should see what it factors to. So now let's divide by taking out a 4r from each of these. 4r squared divided by 4r is just going to be r. 12r divided by 4r is 3, so positive 3. And I'm just going to rewrite the denominator, and hey, look at this. This sometimes happens. We can cancel those r plus 3's, and so our answer is 4r over r minus 3. And yeah, that's what you have to do to simplify this problem all the way. If you left it like this, that would not be quite correct. You'd probably only get half credit because you did add them, but you did not simplify them correctly. All right, at number 13, there's nothing that we can factor. X plus 3, we can't factor that, and neither can we factor x minus 2. There's no GCF, there's nothing squared. So I might just put these in parentheses to show that they're going to stay together, but can't really do anything to them. But yet we are supposed to add these two fractions together, and they do not have the same denominator. So this is a case where if the denominators have nothing in common, you're going to multiply the one fraction by the other's denominator. So I'm going to multiply the first fraction by x minus 2 over x minus 2. Again, the rule is if you multiply the bottom, you have to multiply the top. Then I'll do the opposite to the second fraction. I'll multiply it by x plus 3 over x plus 3, because I know there's more work to do, but now just look at this. The denominators match. X minus 2, x plus 3, x minus 2, x plus 3. And all we have to do now is distribute and combine like terms. So the denominator is going to be our two factors, x minus 2 and x plus 3. The numerator will be x squared minus 2x, because we had to distribute that x. The next fraction is going to have the same denominator, x minus 2, x plus 3. And then we'll have to distribute that one also, so we'll have 5x plus 15. And now let's actually put these together in one fraction with the same denominator, x minus 2x plus 3. X squared does not have any other like terms that go with it, so it's just going to be the same, x squared. But minus 2x and positive 5x, those can be combined. If you combine those, you actually get positive 3x, and then at last we have 15. Alright, at this point, either we're done, we're finished, or maybe we can factor this, maybe we can do something else to it. So I guess what I want to see is, will the numerator factor? The denominator is already factored, but will the numerator factor? Can I put down two parentheses, x and x, and think of two numbers that multiply to make 15 and add to make 3? Well, let's see here. 5 and 3 come to mind, but those do not add to make 3. 1 and 15? No, that doesn't work either. Alright, that's not going to work, so we are done. But you always want to look for a way to try and simplify it, because if it can be simplified, you do need to do that. Alright, let's go on to number 14. Alright, these denominators do not match, but luckily these denominators are also pretty simple. We just have a 3 and a 7. They have nothing in common right now. So we're going to do kind of the same concept that we did in the last one. We're going to multiply the first fraction by 7 over 7, and we're going to multiply the second fraction by 3 over 3. That way, both of the denominators will be 21, because in each case we're doing 7 times 3. On top, we still have to multiply those. 7 times 7n is 49n. The minus sign's still right there in the middle. 9n times 3 is 27n. And now you can actually combine those, 49n minus 27n. And that will actually subtract, because they're like terms. And so you get 22n over 21. Can that simplify at all? Can I divide 22 and 21 by the same number? No. So that is our answer. That's how we would leave it. Alright, number 15. Okay, in number 15, we can see that the denominators do not match. They're not the same. But we're not getting the whole picture here. So if you can factor the denominators, you should do so. And in the first denominator, we're not going to split it up into two parentheses because we don't have an x squared, but we can take a GCF. Both of these can divide by 2. And so we can divide out a 2 and we'll have x plus 4. In the second fraction, both of these can divide by 5. And look at that. We're also going to have x plus 4. Now, these denominators are still not the same. Not exactly. They both have an x plus 4, and that's good. But the 2 and the 5 differ. And so we'll need to multiply each of these to make those into the same number. So you got to think, all right, I need to make 2 and 5 into the same number by multiplying. What number should that be? So basically, you're trying to find the least common multiple. If you're absolutely stuck on this, make a list. 2, 4, 6, 8, 10, 12, 14, and so on. And make a list of 5s, 5, 10, 15. Look for any common numbers, and look at that. 10 is the same. So that means 10 is what we want both of these to become. So in order to make the first one 10, we're going to have to multiply both top and bottom by 5. And so that is going to now say 10x on top, because I had to multiply 5 times 2x. And on bottom, I have 5 times 2. Remember, we wanted to make that say 10. And then I still have the x plus 4 in parentheses. All right, this is going to stay a minus sign. And then the next fraction, I'm going to multiply by 2. So we're going to multiply both the top and the bottom by 2. So on top, we'll have 8 over, on bottom, we'll also have 10x plus 4. Remember, the whole point of multiplying each of these fractions is to make sure that their denominators look exactly the same. All right, let's go ahead and put this into one single fraction. We can't actually subtract 10x minus 8, can we? Because they're not like terms. So either we're done, and that's the answer, or maybe we can factor. We've already factored the bottom. The question is, can we factor the top? And yeah, both of those divide by 2. And so we would have 5x minus 4. And on bottom, this is already factored, 10x plus 4. So the parentheses are not going to go away, because they're not exactly the same. But look at the 2 and the 10. Just imagine if we had 2 tenths. Can you simplify the fraction 2 tenths? Yeah. You can divide them both by 2 and you would get 1/5. So that's what we need to do with this. We need to make 2 tenths into 1/5. So the bottom is going to say 5 parentheses x plus 4. On top, if you want to keep that 1 there, you can, but really you don't need it because when you multiply it, 5x minus 4 on top is just going to stay that way. So this would be the easiest way, or the shortest, simplest way to express your answer. All right, on to the next page. All right, we have some more adding and subtracting with unlike denominators. When you look at 16 and 17, though, actually you notice these aren't even both fractions. So we learned a little follow-up rule in lesson 12.8. So the first thing to realize about these problems is that if one of them is not a fraction, you must change any integers to a fraction by writing the integer over 1. We've done this many, many times before, where we make an integer number into a fraction by writing it over 1. Now, we just compare the denominators. We have 1 and we have x minus 2. And for some people, this is even easier than what we were just doing with numbers 13, 14, 15, because all you're going to do is multiply the number that wasn't a fraction to begin with by the denominator that you already have, and you won't need to multiply the second fraction by anything. So that's what you're going to do to start off, and now each of them will have a denominator of x minus 2, because when you multiply x minus 2 times 1, that's just x minus 2. The second fraction doesn't change yet, and the first fraction you'll just need to distribute. So we'll get 4x minus 8. Now, it might be helpful to think of this x over here as 1x, That way, when you combine it, now that they have the same denominator, you can combine them. You can think about it as 4x plus 1x, and that is 5x, and then we still have minus 8. At this point, either we're finished, or maybe we can do some factoring and canceling. So let's see here. The denominator can't do anything to that. The numerator, you can't divide that either. So no, we are finished. That would be the answer. Let's do another one, number 17. Same type of deal here. So first thing, I'm just going to put this over 1. It might help us to factor this. This is the difference of two squares. We learned this rule a long time ago, back in 2014 in the fall. And so since they're both perfect squares, it's going to factor to x minus 2, x plus 2, and then I basically am not going to think about it as x squared minus 4. So I need to multiply this first term by x minus 2, x plus 2 over x minus 2, x plus 2. Now, the denominators will be the same. So, at first, I'm not really going to change the second fraction here. I'm just going to rewrite it as factored on the bottom. And the denominator of the first fraction is also just going to be x minus 2, x plus 2, because when you multiply it by 1, it doesn't change. It's just going to stay like that. But now I have to figure out a way to multiply this all together. And what I would do is remember to how this originally looked. X minus 2x plus 2 is the exact same number as x squared minus 4. So I'm going to think of this as x squared minus 4, and then I'm distributing a 2 to that. So it's going to say 2x squared minus 8. Now, one more complication with this, and we've talked about this earlier in this review. When you are minusing more than one number, here we're minusing two things, you need to put it in parentheses and distribute that negative sign. So now let's put it all together. I'm going to have 2x squared minus 8 minus x minus 2 all over the denominator x minus 2, x plus 2. All right. Can we simplify this at all on top? Can we combine any like terms? Well, 2x squared, there aren't any other square terms, so that's just going to stay like that. X, there's only a single x term. And then negative 8 and negative 2, those do combine to make negative 10. And we have x minus 2 and x plus 2. All right, either we're finished, or maybe we can factor. We already factored the bottom, but maybe we can factor the top. I'm going to think of this in the middle as minus 1x. And so I'd be saying, okay, can I write this as two parentheses? This would be 2x and x. And can I find two numbers that multiply to make negative 10, where the outsides plus the insides add to equal negative 1? I don't know. I really don't know at this point, but that's what we're going to figure out. All right. So what multiplies to make negative 10? How about, negative 5 and positive 2. So I'm just going to put that in, negative 5 and positive 2. I know that that multiplies to make negative 10. That's why I chose it. What I'm really checking for is, does the outside plus the inside equal negative 1? And I get 4x and negative 5x. Oh my gosh, I got it right in the first try. That does work. 4x and negative 5x, that does factor to make negative 1x. So, if you can factor it, you should factor it. We've seen a lot of those on this review. And now look what we can do. We can cancel those. And so our final answer is going to be 2x minus 5 over x minus 2. That is all that remains. So that is our final answer. Okay. Next, we have complex fractions. They're called complex fractions because they're complicated fractions. Look at number 18. We have a fraction here, plus the whole darn thing is a fraction. So what you're going to do is you're going to rewrite it as the top fraction divided by the bottom fraction. So we're going to basically make this this fraction bar, we're going to make it into a division sign. And the first thing you should do is just recopy it. X squared over y to the third divided by 3x over 9y squared. All right, now, once you have done that one step of recopying it, this problem is now reviewed. This is something that we learned how to do in the first part of Chapter 12 that we've already taken a test over. You know when you divide by a fraction that you're going to need to flip the second one and change it to multiplication. So I'm just going to rewrite the first one, that's not changing. But now the second fraction is going to be 9y squared over 3x. Now that this is multiplication, you can think of the both numerators as just one big numerator, and both denominators as just one big denominator. You can start canceling things between them. However, even though you are allowed to start doing that, I find it helpful to combine it into one fraction. And so when I put these together, I'm going to put it in order. I would usually write the 9, the number first, and then alphabetical order would be x squared, then y squared. Let's do the same thing on the bottom. We want to follow the same order. 3, and then the x, and then the y to the third. And now I'm going to look for what I can divide, what I can cancel. I just think it's easier to line it up like this because you can see what you're dividing. So let's just start with 9 and 3. 9 divided by 3 is just 3. X squared over x, well, there's one more x on top than bottom, so one of them cancels, and we just have x. The y's, looks like there's one more on the bottom than on the top, so there's going to be one y left over, but it's going to be in the denominator. And that's our answer. We can't simplify it any more than that. But that is way more simplified than what we started with, and that's the point. Alright, here is another one. Notice where the big fraction bar is. It's right here. So let's recopy this. Y squared minus 3y minus 40 over y minus 3 divided by y plus 5. Notice that we're actually dividing by y plus 5. It's not y plus 5 as a fraction. Not yet. So you know that you're going to have to flip this one, but that almost doesn't make sense because it's not even a fraction. Well, if I asked you how old you are, some of you would say, I'm 16 years old. But you know you could also say, I'm 16 over 1, and that would be the same number. So when we flip this, originally there's a 1 on the bottom, and then it's going to be 1 over y plus 5. I'm just going to put that y plus 5 in parentheses, because we're not going to be able to factor it. Same thing on the bottom of the first fraction, y minus 3. I'm just going to put that in parentheses, because we won't be able to factor that. However, the first numerator, we will be able to factor that, I bet. 2 parentheses, y and y. What two numbers multiply to make negative 40, but add to make negative 3? So, I don't know, let's try this out. How about 10 and 4? And I know one of them needs to be negative, one needs to be positive. So how about negative 10, positive 4? Those multiply to make negative 40. What do they add to make? What's negative 10 plus 4? That's negative 6. Is that what I want? No, I want negative 3, so that's not going to work. What are the numbers that multiply to make negative 40 but add to make negative 3? Well, they're actually going to be negative 8 and positive 5. Alright, now, can we cancel anything? Yes, we can cancel the y plus 5s. All that's remaining is y minus 8 over y minus 3. That's our answer. If you wanted to put a 1 in, because this 1's there, I suppose you could, but this would actually be the best way of answering it, because it's just the most clear. Alright, we got a couple more of these complex fractions. Let's go to number 20. So first I'm just going to rewrite it. N squared plus 2n over n squared plus 9n plus 18. Make sure when you're recopying it that you copy it correctly. Divided by n squared minus 5n over n squared plus n minus 30. Now, yes, we know we will need to flip the second one, but let's also factor everything. So starting with the first fraction in the numerator, can I factor anything there? Remember, always look for a GCF first. Can I divide anything out of both of these? Yes, you can divide an n out. We had a problem kind of like this on the quiz that we just took, and a lot of people did not do that correctly. So don't forget about greatest common factor. Sometimes I don't even mention it because I know right away there's not one. Like in the denominator here, can I divide something out of all three of these? No. So I go right away to the 2 parentheses, n and n. What two numbers multiply to make 18 but add to make 9? That would be 6 and 3. Now we're going to change this to a times sign, and the n squared plus n minus 30, you could think of that as 1n, that is now going to go on top, but let's factor it at the same time. I know it's going to be n and n. What two numbers multiply to make negative 30 but add to make 1? Well, I know one needs to be negative, one needs to be positive. You can put those in either order. And so it's actually going to be positive 6 and negative 5. And on the bottom, I'm going to have n squared minus 5n. Can I factor that at all? Yeah, we can do a GCF of n. And then I would have n minus 5. All right, the hard part is over. Now for the fun part where we get to cancel anything that is the same on top as on bottom. So n minus 5, those can cancel. N plus 6, those can cancel. This n right here and this n right there can also cancel. So I am left with n plus 2 over n plus 3. It's still a fraction, but that is so much simpler than what we started off with. And that's the point, to simplify it. All right, last one of these, number 21. I'm just going to recopy this. I'll be back in a second. Magic. I have rewritten it in 0 time due to the wonders of video pausing. Okay, so first thing is you just want to rewrite it. You know you're going to have to flip the second one and change this to times, and then we're also going to have to factor everything. You know, the last one that we did, if GCFs is something that you struggle with, where you just divide out a number like here or like here, maybe something that you should do is before you start factoring, just be on the lookout for GCFs. Examine all 4 parts of this and ask yourself, are there any GCFs? So let's do that. In the top here, anything I can divide out of all 3? No. How about on bottom? A, nope. How about this one? No. And this one? No. So there's going to be no GCFs here. All of these are going to break into 2 parentheses. Maybe I'll just do that right away here. I know they're all going to break into 2 parentheses because they all start off with a squared. Not only that, they're all going to be a and a, aren't they? All right, now I'll go back to looking at each one. So with the top of the first fraction, I want 2 numbers that multiply to make 5 but add to make negative 6. Well, since the 5's positive and the 6 is negative, I know they're both going to be negative. It's going to have to be 5 and 1, or 1 and 5. On the bottom, 2 numbers that multiply to make 42 and add to make 13. That's 6 and 7, both positive. All right, now we got to be careful here because we needed to flip the second fraction. So sometimes I like to make a little note just to remind myself that the top of this fraction is now going to be what used to be the bottom. So I'm going to ask myself what 2 numbers multiply to make negative 18 but add to make 3. And let's see here. I know one's going to be positive, one's going to be negative. And that's going to be positive 6 and minus 3. And then lastly, down here, I'm going to be looking at a squared minus 4a plus 3 and asking what numbers multiply to make positive 3 but add to make negative 4. That's going to be negative 3 and negative 1. Or the other way around. Okay, now let's cancel. A minus 3's cancel, a minus 1's cancel, a plus 6's cancel, and I am left with a minus 5 over a plus 7. And that is it. The last lesson that we studied in Chapter 12 is Lesson 12.9, and it's all about solving equations. Solving of an equation is where you end by saying x equals a number. So these are different from any of the problems that we've been doing. None of the other problems that we've been doing did we solve, get a solution where we said x equals something, or a equals something. Now we have 2 ways of doing this, kind of the easier way and the little bit more difficult way. If the equation is a proportion, that means one fraction equals another fraction, and that's it, then you can just set the cross products equal. You can cross multiply. Look at these problems. Do you see any where it's just one fraction equals another fraction, and that's it? If you look closely, 22 and 23 meet that description. These are proportions, so you can just cross multiply. I can do a times 3 on one side, and I can do 4 times a minus 2 on the other side. Now, if you wrote it just how I did there, that's not quite right, because 4 times a minus 2, I don't want to just multiply the a, I want to multiply both of them. I need to distribute. So what we do is we put it in parentheses anytime you're multiplying by 2 or 3 things. On the left side, I'm going to have 3a. On the right side, I'm going to have 4a minus 8. All right, let's get the variables just on one side or the other. I'm going to subtract 4a from both sides. So that will get rid of this. I'll just have negative 8 left over there. On the left side, 3a minus 4a is actually going to be negative 1a. And so then divide by negative 1, and we get our answer. A equals negative 8 divided by negative 1 is positive 8. Now, we need to check this, kind of. Check for extraneous solutions. Make sure they wouldn't make the denominators equal 0. That's all we really have to check for. So there's kind of 2 ways you can go about that. One is to take your number 8, plug it in for the a's on the bottom, and ask yourself, does that make it equal 0? So 4 over 8, does that make the denominator equal 0? No. How about 8 minus 2? 8 minus 2 is 6. Does that equal 0? No, it equals 6. So that means this works. Another way that you can do this is you can take each of the letters and write out the excluded values. This is something that you had to do in the previous chapter, and you were tested over this. So you would say, all right, what would make this first fraction equal 0 on the bottom if a equaled 0? So actually, a is not allowed to equal 0. How about here? What could we put in for a that would make this whole denominator 0? If a were 2, that would make it 0, because you'd have 2 minus 2 is 0. So you don't have to write these out, but sometimes I do, and I'm probably going to do it most of the time here. So this is saying as long as you don't get 0 or 2 at the end, you're okay. And we didn't, so yes, our answer 8 is just fine. All right, here's another one. Notice we just have one fraction equals another fraction, and that is it. So let's cross multiply. Over here, I'm going to have x minus 3 times x minus 6. And I probably should not just write it like that, should I? I need to have parentheses. On the other side, x times x minus 3. Now the right side, you know you can just distribute. We'll get x squared minus 3x. On the left side, you have a couple options for how you want to do that. You can FOIL it, or you can use the box method, whichever way works for you. I'll use the box method. I know a lot of you liked using that, so I'll draw a little box up here. Let me zoom in on that. And I am multiplying x minus 3 times x minus 6, so we'll just do each box. Here, x times x is x squared. Here, negative 3 times x is negative 3x. Make sure you include the sign, that's important. Here, x times negative 6 is negative 6x, and here, lastly, is negative 6 times negative 3. That's going to be positive 18. And notice we have some like terms here, so we can combine those. So let's rewrite this now. It's going to say x squared, and then our like terms are going to add together to make negative 9x, and then plus 18. Okay. Now we need to solve this. We have two different kinds of x's. We have x squared and just regular x. So let's get them all on one side. That might be the way to go. I'm going to subtract x squared first. And oh, look at that. This sometimes happens. They both go away, and we just don't have any x squareds left over. That's going to make this problem a lot easier. From here, I'm going to add 9x to both sides. So I'm moving it over to the right. So I'll have 18 equals 6x, and then divide by 6. And we get our answer, at least we think it's our answer, x equals 3. All right, let's go and check that. All right, if I put a 3 in for x, would that make either of these equal 0? No, so that is good. What would be the answers that are not allowed? Well, 0 would be one of them, and also positive 6 would be one of them. And we didn't get either of those, so we're fine. Now, what if we don't have a proportion? Look at number 24. This is not just one fraction equals another. If only we could just cross this off and cross multiply, but we can't do that. That would be a totally different problem. So what are we going to do here? Well, we are going to multiply every term of the equation by the same numbers to eliminate the denominators. All right. So sometimes what I do is this. I do this right away. I rewrite it, and I leave a space after each fraction because I know that I'm going to be multiplying every one of these fractions by something. The question is, what are we multiplying by? Well, I would like to be able to eliminate, to cancel out the denominators. Let's start with the biggest denominator, which is 6. What would you need to multiply 6 by in order to cancel it out? Well, if we're canceling, it has to be the exact same number. That would be at least what I'd start with, and so it would have to be a 6. So we're going to need to multiply all of these by 6. Let's just see what that looks like. Times 6, times 6, times 6. Now, we are not multiplying both top and bottom by 6. That's what you do when you're adding or subtracting fractions. We're not doing that. We're getting rid of them. So, the question is, will 6 get rid of the 2 and the 3 also? If so, that's good. If not, we may need to multiply by some of these other numbers. Well, let's take a look at the first set. Can 6 and 3 divide? I know they're not the same number, but can they divide by the same number? Well, 3 can divide by 3, and 6 can also divide by 3. So yeah, this is going to work. 3 divided by 3 is 1, and 6 divided by 3 is 2. Over here at the second fraction, can those divide? Yeah, they can also. They both divide by 2, and so we get a 3. And the last fraction, they just cancel out completely because they're the same number. Now notice we have some leftovers. We have 2n and we have 2. Those are going to multiply 2n times 2. And the denominator cancels out. There would be a 1 there, but we don't really need to write that. So that's just going to be 4n. With the second fraction, we have 1 times 3, so that's just going to be plus 3. Now we're on the other side, and the 6 is canceled out, but nothing else canceled out. So we still have 2n minus 3. All right, I'm going to move the 2n over by subtracting it. And so I'll have 2n plus 3 equals negative 3. And then I'm going to subtract 3 from each side. So I'll have 2n equals negative 6. And then divide by 2. And we'll get our answer of negative 3. Now again, we should check this. If I plug negative 3 into the denominator, oh, wait, there's nowhere to even put it in the denominator. So we're going to be good, because it doesn't matter about the numerator. You're not really looking at the numerator. In number 24's case, there are no excluded value. Any number that you would have gotten for your answer would work. So negative 3, it works. All right, number 25. Now, on number 25, we need to get rid of the denominators. We can't cross-multiply them. We're going to have to multiply all of them. But if you can factor any of the denominators, you should, because you'll get a better idea of what that denominator really is all about. So 3a plus 6, you can take out a GCF of 3, and then you'll have a plus 2. It's almost like I'm not even going to look at that original denominator anymore. I changed it. And the second fraction, we can factor a 5 out of that, and we also have a plus 2. So, look at how these three denominators are different and yet still have some similarities. These two both have an a plus 2. So if I'm going to get rid of those a plus 2's, I'm going to need to multiply everything by a plus 2. These two denominators both have a 5, so I'm also going to need to multiply by 5. This one has a 3, so I'm also going to need to multiply by 3. So we're going to take each of these And so I have everything recopied, and we want to multiply all three of these terms by a plus 2, 5, and 3. And you can write them out separately like that. 3 times 5 times a plus 2. So in the first fraction, that's going to cancel the 3 and the a plus 2, but there'll still be a 5 left over. And so we'll have 5a. In the second fraction, we're also multiplying by 3, 5, and a plus 2. And the 5 and the a plus 2 will cancel, but we'll still have that 3 left over. So it's going to say minus, and then a times 3, we can write that as 3a. In the last fraction, 2/5, we're also multiplying that by 3, 5, and a plus 2, even though only the 5 is going to cancel. So we have some leftovers, as I'll call them, the 3 and the a plus 2, and we need to multiply that. So how are you going to multiply 2 times 3 times a plus 2? Well, you're going to do the 2 times 3 first, which is 6, and then you're going to distribute that into a plus 2. So 6 times a plus 2 is going to be 6a plus 12. On the left side, we have 5a minus 3a, and that is 2a. And now it's just a regular equation to solve. I will subtract 6a from each side. So we'll get negative 4a equals 12. And then I'll divide both sides by negative 4. And we'll get our answer, or at least what we think our answer is. 12 divided by negative 4 is negative 3. And so we need to check to make sure that that answer is allowed. If we go back up to the original denominators, you might be able to see that the only answer that would not be allowed, the only excluded value, would be negative 2. Because if you plugged in a negative 2 for a, that would make that equal 0. And we did not get negative 2, we got negative 3. So that is our answer. Alright, number 26. Again, we can't cross multiply here because we have more than just two fractions. Let's factor the denominators to see what we're really dealing with. So in the first denominator, we have x squared and 3x, and those both divide by x. So you can take an x out as a GCF, and you'll have x plus 3. None of the other denominators factor. X plus 3 doesn't, and neither does x. So what are we going to have to multiply by? Let me think about that as I write out all of my terms here. Alright, I have everything written out. And so, another strategy for figuring out what you're going to multiply by is to go one by one through them and just ask yourself, what would I need to multiply by to cancel them out? For instance, starting over here on the right, you could start with any of them really, but over here on the right, if I wanted to cancel out this x, I would have to multiply by x. Now if I multiply that one by x, I have to multiply them all by x. Now in the second fraction, that's not going to cancel out. But in the first fraction they will. In the first fraction, this x right here and this x will cancel out. So that did some good, and we have a leftover right here. So I also need to get rid of the x plus 3. And the way to get rid of that is by multiplying by it. And so that will cancel that out. But the rule is in an equation, if you multiply one side by it, you got to multiply the other side. So I also need to multiply this one by x plus 3. That'll actually be good news because that will cancel out. And I need to multiply over here on the right by x plus 3. That's not going to cancel out, but I still need to do it. And you just do that until you've gotten rid of all your denominators, and we have. That's the whole point. So now let's go back through and see what we have. In the first fraction, everything canceled out except the 3. So we're going to have 3. In the second fraction, these canceled out, but I still have x and x plus 2. So I'm going to need to distribute that, and I'll get x squared plus 2x. And then we have equals. And over here, the x is canceled out, but I have 1 times x plus 3. Well, 1 times anything is just what that number is, so x plus 3. Okay, I can see that this is going to be a trinomial because I have x squared, and I have x, and I have constant numbers. So I'm going to move everything over on one side. I'm going to subtract the x and also the 3. Hey, look at that. When you subtract the 3's, they just both go away. That's convenient. So this will equal 0 on the right, and on the left we'll have x squared plus 1x. All right, how do you solve or factor that? Well, don't forget, look for a GCF. Can you divide both of these by anything? Yeah, you can divide them both by x. And we'll have x plus 1 equals 0, and this is where you can set each of these equal to 0. Either x equals 0, or x plus 1 equals 0, and if you solve that little equation, x plus 1 equals 0, you would get -1. Now before you circle these, remember, we need to check them to make sure they're not extraneous. So go back up to the originals, and what would not be allowed? Well, let's see here. In the first one, and over here, x equals 0 would not be allowed. So 0 is an excluded value. Also, -3. If x were to equal -3, that would make the denominator equal 0. Now, what were our answers again? 0 and -1. Ah, so that means the 0 is not allowed, and you have to cross it off. The -1 is allowed, though, so circle or box that and cross off the other one. Sometimes we write extraneous by it, just to explain why we're crossing it off. It's not really a solution. All right, last problem. So, look at these denominators. Can we factor any of them before we really get started here? N plus 4, n minus 1, we can't factor those. How about this one? I bet we can factor that. So, we're looking for two numbers that multiply to make -4, but add to make 3. One has to be positive, one has to be negative. And the positive one's going to be bigger. I bet it's plus 4 and -1. Yep. So that's what I'm going to look at this bottom one as. And that's what I need to multiply everything by. So I'm just going to move this over a little bit, and I'm going to recopy everything. All right, I have it all written out here. Hopefully this makes sense and is clear to you what's going on. I have the original equation written in black, and we are multiplying each part of that original equation by n plus 4, n minus 1. And certain things will cancel when we do each one. Let's go backwards from the back here, and you notice that all of the parentheses cancel, and we're just left with 2. In the second fraction right here, the n minus 1 cancels, but we still have -1, and then we have n plus 4. We're going to need to distribute that, so it's actually going to be, if we distribute, -1n minus 4. And then in the first fraction, the n plus 4's cancel, and we have 1 times n minus 1. That's just going to be n minus 1. So all this equals 2. And now let's just solve this. Let's just put it together. Do we have any like terms? Let's see here. -1 and -4, together those make -5. N and -1n, oh, that's kind of weird. N and -1n, they will just go away. And so I'm actually left with -5 equals 2. Oh, what did I just do? I just lied to you. That's not true. -5 does not equal 2. And so we have learned that if the variables drop out and you have a false statement, that means there is no solution. It's like this problem was destined to fail from the beginning. There was no way it was going to work. There is no such number that you could plug in for n that would make this left side equal this right side. All right, good luck in your studies.